Hi everyone, it's really a pleasure to welcome you all to your Artificial Intelligence or AI course. In this lecture, we'll review the what, the why, and the who of AI, along with AI applications and history. We'll also review some course logistics and roadmap. So welcome again, and let's get started. First of all, AI has always intrigued people and has been the topic of TV shows and movies for decades. For example, conversing with a computer using natural language has always been a dream for humanity and seen in TV such as Space Odyssey. AI is actually an active and attractive field for the movie-making industry in many ways. It is the perfect candidate topic to craft thrillers, adventures, and dramas and keep people on the edge of their sofa. Like, remember Terminator, AI, Her, Space Odyssey, and HAL, Ex Machina, and so on and so forth. There have been several attempts to define artificial intelligence, but let's start with the most basic definition of intelligence according to the Webster Dictionary. It's the ability to learn and solve problems. This is a definition independently of whether it's human intelligence or machine intelligence. Artificial intelligence, according to Wikipedia, is the intelligence exhibited by machines or software. I'm being more specific here and talking about machines and software that show signs of intelligence. More specifically, according to McCarthy, who is one of the pioneers of artificial intelligence and who even coined the term AI, it's the science and engineering of making intelligent machines. And finally, the definition we adopt in this course is coming from Russell and Norvig, the authors of the famous Artificial Intelligence book. Artificial intelligence is the study and design of intelligent agents, where an intelligent agent is a system that perceives its environments and takes actions that maximize its chances of success. So this is the most specific definitions of all, in which we are talking about intelligent agents and the fact that they perceive their environment and act upon that environment to maximize their chances of success. This is a definition, as I said, that we will adopt in this course. So why artificial intelligence? I would like to refer to this quote from Andrew Ng, who is an active researcher in artificial intelligence and machine learning, who said that just as the Industrial Revolution freed up a lot of humanity from physical drudgery, I think AI has the potential to free up the humanity from a lot of the mental drudgery. So this is beautiful because it just puts artificial intelligence as a second kind of revolution for humanity. So what is artificial intelligence? There are 4 schools of thoughts according to Russell and Norvig. The first one is about acting humanly, in which several researchers defined it as how to make computers have a mind or think. One of them is Hoagland in 1985 that says that it is the exciting new efforts to make computers think, machines with minds in the full and literal sense. The second school of thought is about acting humanly, as defined by Rich and Knight in 1991, as the study of how to make computers do things which at the moment people are better at. The third school of thought is about thinking rationally, in which we want to study the mental faculties through the use of computational models. So we started talking about computational models to mimic the brain or to mimic our mental faculties. And finally, the last school of thought is about acting rationally, as defined by Poole and al. In 1998, which is computational intelligence is the study and the design of intelligent agents. We start talking about intelligent agents in 98, in which we want to design those systems. We don't talk anymore about making the machine has a mind or making the machine think rationally or making the machine act humanly. We want to machine to act rationally rather than humanly. So first of all, let's go through these schools of thought individually. The first school is about thinking humanly, also called the cognitive approach, in which we want to design machines with what? With minds, machines that think in the full and literal sense. This requires first to determine how human thinks. It was actually in the 60s when this kind of cognitive revolution started. It requires scientific theories of internal activities of the brain, understand what level, answer questions like what level of abstractions, is it knowledge or secrets, and how to validate the knowledge. Today, cognitive science and artificial intelligence are distinct disciplines, and we really we don't want to have machines with minds, but we want to understand how the brains function. This is part of the cognitive science field. The second school of thought is about acting humanly, in which case we want to have machines do things just like humans do things. And this school of thought started with Alan Turing in 1950 when he published his paper, Computing Machinery and Intelligence, in which he defined what we call the Turing test, or the imitation game. In his test, he actually deemed a computer to be passing a test of intelligence if it can fool a human interrogator. So to picture this, we have a human interrogator on one side, and there is a wall separating this human interrogator from another human and another AI system. So the human interrogator will be asking questions to the other side of the wall, and an AI system would be deemed as intelligent if the human interrogator can tell which is the AI system from which is the human. So it says that it fooled the human interrogator, and it showed that it exhibits some form of intelligence because it was able to do that. So in his paper, Alan Turing also suggested major components of AI, including knowledge reasoning, language understanding, and learning. He also suggested in his paper major components of AI, including knowledge, reasoning, language understanding, and learning. And he finally anticipated many of the problems or many arguments against AI that's coming up in the next 50 years. Acting humanly or making machines do things has actually inspired many discoveries, including flying. So the flying is one example in which actually we made the machine do things based on what we observe in humans and in animals. For example, we know that birds can fly, so the concept of flying, the proof of concept, is out there. We know it's possible to fly, but then the process to fly has been invented by humans. We don't see airplanes flapping their wings. However, airplanes use similar, have the same effect of flying using different principles, including aerodynamics processes, etc., etc. So acting humanly has inspired discoveries, even though the process at the end has been different from what we observe in nature. The third school of thought, also called thinking rationally or laws of thoughts, involves using math and logic to do artificial intelligence. It's about codifying the right thinking with logic. And it all started with several Greek schools that developed various forms of logic, such as first-order logics, propositional logic, and more. It uses some notations and rules of inference or derivations for thoughts. And the idea is to codify all knowledge in these representations and use it to derive new knowledge. The problems with this is that, first of all, not all knowledge can be expressed with logical formulations. Sometimes, for example, to express time or space, it's hard and can lead to complicated logical formula for that. And finally, it also leads to computational blow-up if you want to consider all possible factors that come into play with logic, if you want to use all possible factors that come to play with logic. And finally, the last school of thought is about acting rationally, design intelligent systems that actually act to maximize their goal. It's about agents that do the right thing, that which is actually expected to maximize the goal achievement given the available information about the environment, the background knowledge, etc. So we want to devise in this school of thought rational agents that is actually one that acts to achieve the best outcome on when there is a stochastic environment in means uncertainty. We want to achieve the best expected outcome given these agents. So we quote here Aristotle when he said, "Every art and every inquiry, and similarly every action and pursuit, is taught to aim at some good." This is exactly the spirit of this school of thought in designing intelligent agents. Finally, in this course, we are going to adopt the fourth line of research, or fourth line of thought, which is acting rationally, or how to divide intelligent systems that act rationally in order to achieve their goals.